And here we go. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@yvcc.edu and I'll respond as soon as I can. All right, so today, we're going to go on to section 6.3. We're going to spend 2 days on it. Today, we're going to look at factoring by grouping, and tomorrow we'll look at a different method of doing the same thing. But before we do that, do you have any questions from yesterday, from 6.2? Anything there you'd like to look at before we proceed? All right, I'll take that as a no. So we're going to take a look at 6.3, and this is factoring trinomials in the form ax squared plus bx plus c, where a no longer will be a 1. So it could be a larger number, a fraction, a smaller number, but the rules change. Things get a little more complicated when the leading coefficient is something other than 1. So that's what we're going to look at today. Again, one of two methods we're going to study to factor those trinomials. All right, so let's just get right down to business, and I'm going to take an example, which is 3x squared plus 4x plus 1. This is in standard form, as in ax squared plus bx plus c. So the coefficients, a is 3, b is 4, and c is 1. Do you have any questions about where I got the 3, 4, or the 1? Okay. Now, as with yesterday's, we're going to find a product and a sum, except things are a little different when the leading coefficient is other than a 1. The product is going to be a times c, and the sum is still going to be equal to b, the middle term coefficient. So in this case, the product would be what? 3 times 1, which is 3, and the sum would be 4. So again, any questions where I got the 3 or the 4? Okay. Now, we're still looking for a pair of numbers whose product is that 3 and whose sum is 4. So the numbers would be 3 and 1, because 3 times 1 is 3 and 3 plus 1 is 4. But now, instead of just taking those numbers and putting them right in the answer, we take this trinomial and we take the middle term and we split it up into 2 terms, okay, whose coefficients are those 2 numbers. Now, the 1 that I put in front of the x doesn't need to be there. I could have just written plus x, but I'm just wanting to emphasize where these numbers came from, okay? Now that we've split the middle term into 2 terms that have these 2 coefficients, we're going to use factoring by grouping to continue factoring this polynomial. So I'm going to split it up into 2 groups. The greatest common factor of the first 2 terms is 3x. The leftovers are x plus 1. So over on the right side, the leftovers have to be x plus 1. And outside, in front, I need a plus 1 as well. So then taking out the greatest common factor and the leftovers, we get this answer. Any questions about any parts of the procedure? Incidentally, I call this the ABCPS method because you have to locate and find A, B, C, P, and S. Okay, but it's also the grouping method, which is what it's called in the textbook. All right, well, let's go on to another example. 2b squared plus 7b plus 3. Now, the variable is b in this case, but when I talk about A, B, C, P, and S, I'm talking about the coefficients, 2, 7, 3. The The product is A times C, which is 6. The sum is B, which is 7. Again, any question about where any of those numbers came from? So I'm looking for two numbers whose product is 6 and whose sum is 7. How about 6 and 1? The product is 6, the sum is 7. So I'm going to take my original trinomial, split the middle term into two terms whose coefficients are these two numbers. Okay, so again, there's an implied 1 here. Now, using factoring by grouping, the greatest common factor of the first two terms is 2b. The leftovers are b plus 3. So over on the right side, the leftovers are b plus 3, and I need a plus 1 outside. The greatest common factor is b plus 3, and the leftovers are 2b plus 1, and there we have the answer. Let's check our work. This would be 2b squared plus b plus 6b plus 3, 2b squared plus 7b plus 3, and it checks. So there is the correct factoring. Everybody okay? Any questions? All right, we'll continue. Let's see here. 5n squared plus 12n plus 7. Now, again, this is a trinomial. It's in standard form of descending powers. The leading coefficient is not a 1. So a is 5, b is 12, c is 7. The product is a times c, or 5 times 7, which is 35. The sum is equal to b, or 12. So I'm looking for two numbers whose product is 35 and whose sum is 12. Well, how about 7 and 5? 7 times 5 is 35. 7 plus 5 is 12. So I get 5n squared plus 7n plus 5n plus 7. Again, splitting the middle term into two terms whose coefficients are those two numbers. But you've got to go through this process to figure out what those two numbers are. You can't just break apart 12 in any old way you want. You have to break it apart such that you've got two numbers whose product is this and whose sum is that. And now, factoring by grouping, the greatest common factor of the first two terms is n. The leftovers is 5n plus 7. So over here, the leftovers is 5n plus 7. We have a plus 1 out in front. The greatest common factor is 5n plus 7. Leftovers n plus 1. So again, any questions on this? All righty, let's take a look at this one. 15a squared minus 28a plus 5. This is a trinomial. It's in standard form or descending powers of the variable. Oh, and I should mention, there's no greatest common factor I can take out. The leading coefficient is not a 1. So a is 15, b is negative 28, and c is 5. Now this a is not referring to the variable. It's referring to the coefficients. There's a, b, and c. So don't get confused with that. The product, 15 times 5 is 75. The sum is b, or negative 28. Let's talk about signs again. We've got a positive product, so we've got to have two positive factors or two negative factors. But the sum is negative. So our two numbers have to both be negative. So I could go with negative 75 and negative 1. How about negative 25 and negative 3? That would do it, wouldn't it? That would give me a product of 75 and a sum of negative 28. So I've got 15a squared minus 25a minus 3a plus 5. Again, splitting the middle term into two terms whose coefficients are those two numbers. And then using factoring by grouping, the greatest common factor of the first two terms is 5a. The leftovers are 3a minus 5. On the right side, the leftovers are 3a minus 5. And let's see, I'm going to have to factor or take out a minus 1, right? So that gives me minus 3a plus 5. Now the greatest common factor is 3a minus 5, and the leftovers 5a minus 1. Okay, let's see here. Let's do this one. 7x squared plus 33x minus 10. This is a trinomial. It's in standard form or descending powers of the variable. There's no greatest common factor, and the leading coefficient is something other than a 1. So a is 7, b is 33, and c is negative 10. The product is a times c. 7 times negative 10 is negative 70, and the sum is b, or 33. I'm looking for two numbers whose product is negative. So I have to have a positive factor and a negative factor. But when I add those two numbers as a sum, the result is positive. So that means the bigger number, or the one with the higher absolute value, has to be positive. So I'm talking a big positive, little negative. How about 70 and negative 1? No, that's too big. How about 35 and negative 2? Cut that in half, double that. Ah, there you go. 35 times negative 2 is negative 70. 35 plus negative 2 is positive 33. So we're going to take our trinomial and split the middle term, 35x minus 2x, and then minus 10. Factor by grouping, greatest common factor of the first two terms, 7x with an x plus 5 left over, x plus 5 left over here, and a minus 2 out in front there. Greatest common factor, x plus 5, leftovers, 7x minus 2. Let's check our work. 7x squared minus 2x plus 35x minus 10. Combine like terms, 7x squared plus 33x minus 10, and it checks. Okay. Again, if there's any questions, anything you want me to slow down, go back on, please stop me. Here's another one. 4b squared plus 15bc minus 4c squared. So here we have a trinomial. It is in standard form in terms of b. It is not in standard form in terms of c, but if it ain't broke, don't fix it. So we'll go with it in terms of b. There's no greatest common factor, and the leading coefficient is not a 1. So a is 4, b is 15, c is negative 4. The product is a times c, or negative 16, and the sum is 15. So we've got a negative product. That means one of the numbers has to be positive and one of them has to be negative. The sum is positive, so the bigger number has to be positive. How about 16 and negative 1? Bingo. There's a product of negative 16 and a sum of 15. So we get 4b squared plus 16bc minus 1bc minus 4c squared. Factor by grouping, the greatest common factor of the first two terms is 4b. b plus 4c left over, so b plus 4c left over minus c out front. That gives me minus bc and minus 4c squared, so that works. Take out the greatest common factor and the leftovers follow. Okay, let's see here. How about this one? 16r minus 40r squared plus 25r cubed. What's wrong with this problem? Anybody? No volunteers? Okay, well, I'll tell you. It's not in standard form. It's not in descending powers. So we're going to rewrite it. 25r cubed minus 40r squared plus 16r. So now it's in descending powers of r. There's a greatest common factor. We can take out an r. So we've got r times 25r squared minus 40r plus 16. Okay, so we've put it in standard form. We've taken out the greatest common factor. The trinomial that's left inside the parentheses, we're going to deal with that. It doesn't have a leading coefficient of a 1. A is 25, B is negative 40, and C is 16. The product is 400, and the sum is negative 40. Okay, so we have a product that's positive. So both numbers, both factors have to be positive or both factors have to be negative. But since the sum is negative, we can't get a sum that's negative if you add two positive numbers. Therefore, the two numbers we're looking for must both be negative. Okay? Let's see. Here's what I'm going to do. I'm going to take this and I'm going to rewrite it up here so that I have more room to work with. Okay? I know I need two negative numbers. How about negative 400 and negative 1? That would give me the correct product, but the sum would be negative 401. So I'm a long ways from where I need to be. But I could take negative 400, since it's even, I could split it in half and consequently double the second number. That would still give me a product of 400, but it would give me a sum of negative 202. I'm getting warmer. Now, some of you may already see that the answers are negative 20 and negative 20. And if you can, that's great. But I'm just trying to give you a method to get there if you can't just see it. All right, negative 200, negative 2. How about if we split this in half because it's even and consequently double that? I still have a product of 400, but now my sum is negative 104. Getting warmer. Cut this in half, double that. My sum is negative 58. Cut this in half, double that. My sum is negative 41. I'm oh so close. I'm trying to get negative 40. Well, I can see that I'm headed in the right direction. The first number is getting technically larger because it's getting a smaller negative, so to speak. And the second number is getting more negative. So I need two numbers in here between negative 25 and negative 16 that go into 400. Well, let's see. Negative 21, negative 22, negative 23, negative 24. None of those go any. How about negative 20? Okay. What's negative 20? Oh, negative 20 times negative 20 is 400. And the sum is negative 40. So there's my two numbers. Now, again, if you could look at the original numbers and see that, oh, it's negative 20 and negative 20, you don't have to do all of this. But this is just a method to get there, to kind of narrow the field. So now I'm going to take this and I'm going to have r times the quantity, 25r squared minus 20r plus 16. Okay. Again, splitting the middle term into two terms that have these two coefficients. Using factoring by grouping, r, I'm going to switch to parentheses. Let's see, 5r, and then I'm going to have a 5r minus 4. So this is going to be a 5r minus 4 and a minus 4 outside. Okay. Well, I've run out of room, but I think I can get the answer to fit right over here. So I'm going to have r times 5r minus 4, but my leftovers are also 5r minus 4. So there's my final answer. However, since the two binomial factors are identical, I could also say or 5 times the, whoops, not 5 times, hang on, slow down here. I would have r times 5r minus 4 the quantity squared. Let me write that bigger up here. R times 5r minus 4 the quantity squared. So you could write it that way, or you could write it that way. Sorry, I'm all over the place there. I didn't plan ahead very well and ran out of room. Any questions on this problem? So we had to do a lot here. We had to put it in descending powers. We had to take out the greatest common factor. Then we had to take the trinomial that was remaining inside the parentheses and factor it further. Okay, let's see. How are we doing? Let's do another one of those. 70a squared minus 95a plus 30. Well, this is in standard form. How's the voice today? But there's a greatest common factor. Can anybody tell me what it is? All right, fine. You're going to be the silent type. That's fine. I'm going to take out a 5. That's going to give me 14a squared minus 19a plus 6. Let's see, 5 times 14 is 70. 5 times negative 19 is negative 95, and 5 times 6 is positive 30. Okay, so I've got a greatest common factor taken out. Now, my trinomial that's left has a leading coefficient that's a 14, so it's not a 1. So A is 14, B is negative 19, and C is 6. Product is what? 84, and the sum is negative 19. Again, 14 times 6, 84. Let's see here. I've got a positive product, so two factors that are both negative are both positive. A negative sum, so both factors have to be negative. Let's try negative 84 and negative 1. That would give me a sum of negative 85. How about negative 42 and negative 2? That would give me a product of 84 and a sum of negative 44. How about negative 21 and negative 4? Again, I'm just splitting the first number in half and doubling the second number. It still gives me a product of negative or of 84, but the sum is now negative 25. Well, I keep getting warmer, but I'm not quite there yet. So I need two numbers between negative 21 and negative 4. Well, let's see. Negative 20 doesn't go into 84 evenly, so it couldn't be negative 20. How about negative 19? Let's see. 84 divided by 19. No, 19. 18. 84 divided by 18. 17. 84 divided by 17. 16. 84 divided by 16. 15. 14. Wow. Can you think of anything? Maybe I should try the smaller numbers. Let's see. 5, 6. Oh, 6. 6 goes into 84, doesn't it? Yeah. How many times? 14. So negative 14 and negative 6. That gives me positive 84. But my sum is still not quite there yet. But I've narrowed the field a little bit. So I need two numbers between negative 14 and negative 6. What if let's see here. I'm running out of room there again. What if I cut that in half and double that? Oh, there we go. Negative 7 and negative 12. Now, again, this process may seem long and tedious, but I'm saying if you can't just jump right in there and see those numbers, this is a way of narrowing it down to where you're not looking at a huge area, but you're looking at a smaller area. Okay? So now I've got my two numbers. So this becomes 5 times the quantity 14a squared minus 7a minus 12a plus 6. Factoring by grouping, 5 times, let's see, the greatest common factor is 7a with 2a minus 1, 2a minus 1, and a minus 6. 5 times 2a minus 1 times 7a minus 6. And there's the final answer. The most common mistake that students make is they let that common factor we took out at the beginning disappear, and they don't put it in their final answer. You've got to take it all the way along with you. Okay. Let me make this a little bit easier to read. Okay, let's see here. How about this one? 8m squared plus 5m minus 10. So here we have a trinomial that's in standard form. There's no greatest common factor other than a 1. And the leading coefficient is something other than a 1. So I'm going to use the ABCPS, or the grouping method. A is 8, B is 5, C is negative 10. The product is A times C, or negative 80, and the sum is 5. So I've got a negative product, which means I have to have a positive factor and a negative factor, or a negative factor and a positive factor, okay, one of each. But the sum, when I add those two numbers with different signs, the sum is positive. So the absolute value of the positive number has to be bigger than the absolute value of the negative number. So I need a big positive and a little negative. So consequently, rather than starting out with, say, negative 80 and 1, I'm going to start out with positive 80 and negative 1, because I know my positive number has to be bigger. Well, let's see. This would give me the right product, but a sum would be 79. We're a long ways from home. I can take 80 and cut it in half, and consequently double the negative 1. So now I've got 40 times negative 2 is negative 80, and the sum is 38. We're getting warmer. I can cut 40 in half and double negative 2. 20 times negative 4 is negative 80, and the sum is 16. We're getting warmer. I can take 20 and cut it in half, and take negative 4 and double it and get negative 8, and the sum is 2. Oh, look, I've gone too far. The number I'm seeking is right in there, right? 5 is between 16 and 2. So that means the pair of numbers that I'm looking for, one of them has to be between 20 and 10, and one of them has to be between negative 4 and negative 8. Well, there's less numbers between negative 4 and negative 8 than there are between 20 and 10. So one of my numbers, my negative number, would have to be negative 5 or negative 6 or negative 7, okay? Well, negative 6 and negative 7 don't even go into negative 80 evenly. So the only possibility is negative 5. Well, let's see. How many times does negative 5 go into negative 80? Let's see. We have negative 80 divided by negative 5. We get 16, okay? So that's the only possibility that could go in here that would give us negative 80. What's the sum? It's 11. What's my conclusion? Anybody?
Prime.
Good job. It's prime. Now, here is the wrong way to go about trying to see if a trinomial is prime. Just randomly picking some numbers, and you try a few and none of them works, so then you say, oh, it's prime. No, you want a process. By doing this, I narrowed it down to where I knew it had to be a negative 5, a negative 6, or a negative 7 as one of the numbers. And these two didn't go into negative 80 evenly. So this was the only possibility between these two. And since it didn't work, now I know for sure it isn't prime. One of the biggest mistakes students make, especially on a test, is they'll be trying to determine if something's prime. They'll try a few things and then they'll just give up and say it's prime when it isn't. You've got to have a process. So I recommend this. Okay, let's see here. Let's take a look at this one. 6s to the 5th power minus 26s to the 4th power minus 20s to the 3rd power. This is a trinomial, and it is in standard form in terms of s. But there's a greatest common factor. Right away, I see, since every term has s in it, I know I can take out an s, but in fact, I can take out s cubed. All the coefficients are even, so I can take a 2 out. I don't think I can take any number larger than a 2, so I'm going to take out a 2s cubed. And let's see what's left over. I'd have 3s squared minus 13s minus 10. Let's see, 6x to the 5th minus 26s to the 4th minus 20s cubed. That looks good. And 3s squared minus 13s minus 10. There's no common factor there. So I took out my greatest common factor correctly. And the leading coefficient isn't a 1. Inside it's a 3. So A is 3. B is negative 13. C is negative 10. The product is negative 30. And the sum is negative 10. The product is A times C. And the sum is B. I'm looking for two numbers whose product is negative 30 and whose sum is negative 10. The product is negative, so I've got to have a positive number and a negative number. The sum is negative, so the bigger number has to be negative. So how about negative 30 and 1? Well, that would give me a sum of negative 29. How about negative 15 and 2? That would give me a sum of negative 13. Well, I'm not there, but I'm getting closer. So my two numbers need to be between, let's see, one of them, the negatives are going down and the positives are going up, aren't they? Let's see. What could I do? Oh, I could take a 3 out of negative 15 and make it negative 5, and then times 3 would be a 6. That would give me what? 1. That's gone too far, hasn't it? What about this? What if I had a 3 and a negative 10? What would that give me? It'd give me negative 7. Let's see here.
Isn't the sum supposed to be negative 13?
Thank you. Yes. I was going nuts here. Way to go, Ben. Thank you for that, for correcting me there. Yes. I'm going, what is going on here? Okay. My problem is I'm thinking ahead instead of where I am, and that's not a good idea. I need to be where I am instead of one step ahead. That's my excuse. Not a good one, but I'm going to stick with it. This is going to make life so much easier. How about, I was thinking, oh, negative 10 and negative 3, but that's not right, is it? Because that gives me a product of positive 30. How about negative 15 and 2? Yeah, if I'd only written the right number for the sum, I would have been done hours ago. So there's the two numbers. Okay, so now what have we got? We've got 2s cubed, 3s squared minus 15s plus 2s minus 10. Okay. So split it up. We've got, let's see, 2s cubed. Greatest common factor, 3s times s minus 5. So this is s minus 5, and outside we're going to have a plus 2. That's going to give me 2s minus 10. So I've got 2s cubed, s minus 5, 3s plus 2. There we go. Again, thank you for sparing me. I know you were all painfully being tortured, probably thinking, what is this guy doing? I'll just crawl over to the corner and weep softly now. Well, we continue here, but okay. And of course, now no one's going to believe anything else I say because my credibility has been shot, but we'll see what happens. Okay, how about this one? Negative b squared minus 5b plus 24. This is a trinomial. It's in descending powers or standard form, but it doesn't have a leading coefficient of a 1. It has a leading coefficient of a negative 1. So the first thing we're going to do is we're going to just factor out that negative 1. Okay? Now, I have a trinomial with a leading coefficient of a 1. So I don't need to use this whole grouping thing. Okay? This takes us back to section 6.2. The product is negative 24 and the sum is 5. Now I could use grouping on this, but it would just make it longer. So you don't need to use grouping if the leading coefficient is a 1. Okay, let's see. How about negative 8 and 8 and negative 3? That would do it, wouldn't it? So plus 8 minus 3. And again, I put those right in the answer. I don't have to split the middle term and do all of that stuff when this leading coefficient right here is a 1 or an implied 1. Don't make it harder than it has to be, like I did in the previous problem, screwing up the number. Okay. Any questions there? All right. How about this one? 9x to the 4th plus 27x to the 6th. Well, this isn't a trinomial. It's a binomial. Is there, oh, there's a greatest common factor. In fact, we could take out 9x to the 4th. So I need to have a 1 here plus 3x squared. Why do I need that 1 there? So that I can get back there by distributing, okay? If you just wrote this, that's only going to give you that term. So that 1 is critical, okay? So 9x to the 4th times the quantity 1 plus 3x squared. Let's see here. 4y squared plus 36y plus 72. Here's a trinomial in standard form. Oh, there's a greatest common factor of a 4. So we'll take that out. Y squared plus 9y plus 18. Now my trinomial has a leading coefficient of a 1. So I don't have to use grouping. My product is 18 and my sum is 9. I'm no longer dealing with this. I'm dealing with this, right? So here's my numbers I look at. How about 6 and 3? So plus 6 plus 3. A question that somebody usually asks, but nobody asked yet. So I'm going to go back and do another problem, and I'll just ask the question myself. Okay, 14y squared plus 11y plus 2. So here we have a trinomial. It's in standard form. There's no greatest common factor. The leading coefficient is not a 1. So we'll use grouping or ABCPS. A is 14, B is 11, C is 2. The product is 28 and the sum is 11. Okay. Well, let's see. How about 7 and 4? Okay. So 7 times 4 is 28. 7 plus 4 is 11. So I've got 14y squared plus 11y plus 2. Okay. Oh, what should I have done? I should have gone ahead and split it up. So this is what? Plus 7y plus 4y plus 2. Grouping, we get 7y, 2y plus 1, 2y plus 1, plus 2 outside, 2y plus 1, 7y plus 2. Okay, now, maybe I should put those a little bit closer. A question people usually ask is, well, does it matter which order I put those numbers? In other words, I wrote 7y plus 4y. Could I have written plus 4y plus 7y? And this is where some of you are going to go, yeah, I was thinking of that. I just didn't want to ask. So I asked for you. So then you'd have what? 14y squared plus 4y plus 7y plus 2. In other words, if I switch those two terms around, still factoring by grouping, now my greatest common factor is 2y, and the leftovers are 7y plus 2. And over here, 7y plus 2 with a plus 1 outside, 7y plus 2, 2y plus 1. Do I get the same answer? Yes, I do, but the two factors are commuted, and we've talked about how multiplication is commutative. So it doesn't really matter which order you split those two terms, which one's first or which one's second, you still should get the same final answer. Okay. How about this one? 15c squared d cubed minus 25c cubed d squared minus 10d to the, or oops, okay, minus 10c to the fourth d to the fourth. Okay, this is a trinomial. Wow, it's not really in standard form in terms of C or D, is it? It's got a greatest common factor. I'm going to take the greatest common factor out first just to see what I've got left to work with. I can see I'd take a 5 out and a C squared and a D squared. So I've got 3D minus 5C minus 2C squared D squared. Let's make sure that's correct. Let's see. That would be 15C squared D cubed, check. Minus 25C cubed D squared, check. Minus 10C squared D squared. Or C to the fourth, D to the fourth. Okay. So look at this. That's a trinomial, but it's not going to factor. I mean, I could rearrange things and I could say, well, let's put, let's go negative C, 2C squared D squared minus 5C plus 3D. So I've got C squared, C, no C at all. But it's just, it's not going to factor any further. Now, be careful. What you don't want to do is say, oh, it's prime. This part of it, true, it doesn't factor any further. But for a polynomial to be prime, that means that you couldn't do anything from the very beginning. And we did take out a greatest common factor. So the final answer would just be the greatest common factor times that trinomial inside. But again, it's not prime, okay? For it to be prime, you can't do anything, can't take anything out. All right? Okay, well, I'm going to go ahead and stop the recording.